On April 12, 2011, a semi-submersible accommodation platform called Jupiter 1 started listing in the Gulf of Mexico as a result of an incident in the portside pontoon. This 9,451-ton accommodation platform was located at an offshore complex in Bay of Campeche and held a total of 745 people.
Jupiter 1 is a semi-submersible accommodation platform. While it was parked next to a fixed platform, it started taking on water in its starboard floater, and that made the catamaran-style vessel to turn.
A rig like that, you can feel it going over, and then once it starts to get about 2 degrees, you start getting nervous about 3 degrees, you really get nervous, and then by the time it's 5 degrees, you're getting off.
As soon as the structure began to sink, workers were evacuated and various rescue efforts were put in place, starting with vessels and support from other contractors to prevent additional movement.
I was part of the first responders when the incident happened. When we arrived, all we see is the pontoons floating. The life raft were still in the water. It was chaos at that moment.
They needed to do something to stabilize it, so they built a stabilization barge, which they anchored out away from the Jupiter and ran chains to the Jupiter and tensioned it up.
Despite these precautionary measures, Jupiter 1 could not be stabilized and ultimately capsized on April 17, 2011. It fell inside a jacket under an accommodation platform close by, overturning approximately 140 degrees of the horizontal upright position, only 7 meters away from active pipelines.
When it capsized, some areas were leaning against the jackets of the Alcatún Alpha. It was putting pressure on the rig itself.
The Alcatún Alpha platform, it's a group of platforms tied together. It's responsible for quite a lot of the Mexican oil production.
It has a lot of stations with compressors and tanks and pressure systems to send the oil ashore. So it's very, very important for that area of the Mexican Gulf.
Fortunately, there were no casualties and no oil was leaked during the incident. The wreck location denoted a major risk, especially since it happened during the Atlantic's hurricane season. Jupiter 1 was completely surrounded by numerous production pipelines and wells from the Abcatun A field, while holding several diesel and jet fuel barrels. Any slight movement or damage caused by extreme weather conditions could have been catastrophic.
It was the North Atlantic hurricane season, so the potential for catastrophic disaster in case of a hurricane would be quite high.
Everybody was afraid that if a front comes, the swell action was going to be so great that it will push onto this jacket and make the entire fixed platform collapse.
If the hurricane had come, the weight of the Jupiter, as she was leaning against the structure, if she'd gone over, would have damaged at least that portion of the platform, or the storm could have pushed it anywhere in the field and damaged the pipelines.
We couldn't get the Jupiter to either go against the barge or to float away from the barge because it will damage something and there will be a big environmental problem there.
All these circumstances painted the ideal scenario for an impending disaster, risking a huge oil spill that could have been worse than the Macondo catastrophe or the historic Ixtoc 1 oil spill that took place in the same Gulf of Mexico area. The Macondo blowout is one of the largest oil spill disasters in the history of oil production. It started on April 20th, 2010, when a drilling rig had a blowout in the Gulf of Mexico. The rig ended up burning and sinking 2 days later, causing an offshore spill of approximately 4.9 million barrels of crude oil. With a nightmare waiting to happen in their hands, owners and underwriters, together with consultants, reached out to the salvage industry. The complexity of the wreck and challenging conditions warranted a high level of engineering, equipment, and experience. Mammoet Salvage stood up to the challenge and developed an inventive solution.
The dimensions between the two floaters, when you put it upside down, was exactly 100 feet. So a 300 by 100 foot barge would fit nicely in between the floaters.
They would refloat the accommodation platform upside down, hang it under a lifting barge, move it out of the field, and scuttle it in deep water. The barge, however, was yet to be built.
Our tender kind of combined two things. One was refloating the rig upside down, and as a contingency we parked the barge in between and we added 12 chain pullers, creating another 3,600 ton of lifting capacity.
The calculations or the condition of the rig showed that she could float on her own if air was used, but that wasn't good enough. So we had to have another method to add buoyancy, which was the salvage barge with the chain pullers over the side, giving additional lift to the Jupiter, and then giving an operational base for support of the dive barge, which was adjacent to the Jupiter.
In this condition, we could lift the rig up and we could move it across pipelines out of the field into an area where it would not be a hazard to the oil and gas industry.
This plan led them to win the tender process and ultimately sign a contract with the owners. Mammoet led the entire operation and subcontracted part of the work for further support to American Salvage Association members, Global Diving and Salvage, Titan, TNT BISO, and Resolve. The salvaging process officially kicked off on May 16, 2011, starting with 2 parallel operations, shipyard work and the offshore preparations. The engineering work involved building Ulysses, a one-of-a-kind barge with a 3,600-ton lifting capacity.
Ulysses was the name of the lifting barge that the owner had named it. And it was very befitting for this project because it was the start of a great journey for us, much as the Greek name for Ulysses, Odysseus, went on his great journey, the Odyssey.
What made this barge so unique was the wave compensation system, which involved custom-made stretchers that were meant to minimize wave movement during the operation. All of this demanded thorough research as well as an extensive testing program to determine what kind of material would be required in construction.
The wave compensation system was necessary because the movement of the Jupiter would ride on the waves. And if we had just chains secured to the Jupiter, when the rig would settle in a wave, then it would put a shock load on the chain. The compensation system was designed and built to take some of that shock load out.
Ulysses' lifting arrangement consisted of 12 wave compensated chain pullers and comprised the fabrication of assembling 12 steel support beams, as well as heavy high-grade steel wildcats to guard the lifting chains. While engineering efforts were put in place, the diving team proceeded with the offshore preparation process, where they were able to remove all oil, pollutants, and environmental hazards from Jupiter 1, as well as identify tanks, install rigging, and establish air connections.
For about 27 to 29 days, that's all we did was debris removal. On the barge itself, on the Jupiter, we connected several ocean sensors. They were directly connected to a computer on board the support vessel, and it pretty much was monitored 24/7. We had an ROV that was in the water during the daytime and assisted the motion sensors to see movement. So everything was well thought and planned.
The outfitting of Ulysses was placed in New Iberia, Louisiana, and towed to Mexico when completed. A 3,600-ton lifting crane typically takes years to develop. However, Mammoet engineered and built this barge in 6 weeks and placed it right in between Jupiter 1's pontoons by the beginning of July.
To assemble the barge by itself is already quite an engineering miracle.
Engineer would be up all night designing something for modification in the morning. And then we had 24-hour welders. They would take the drawings and start putting them into effect.
In about 6 weeks' time, we built a 3,600-ton offshore wave-compensated lifting crane.
When on site, the crew established a wire connection with the 400L, a stabilization barge that was already in place to pull Jupiter 1 away from the platform, and that would also assist on stabilizing and anchoring Ulysses during the lifting operation.
The 400L was where all the diving operations were run, and the divers had to come underneath the outer pontoon to connect the chains. From the lift barge, the divers could be supported with crane because it was directly over where they were working.
Planning for the tow-out, Mammoet first surveyed the route and prepared Jupiter 1 to be pulled over numerous active pipelines, a circumstance that intensified the risk of the operation. Preparation included cutting off a crane as well as all loose and hanging equipment to prevent them from hitting pipelines while crossing the ocean. Next, The team proceeded with refloating, which consisted on using the chain puller system and air pumping process to lift, shift, and stabilize Jupiter 1 away from the jacket. Once the platform was stable and floating in an inverted position, it was ready to be towed to its scuttle site. At the very end of the tow-out process, Mammoet had the platform in perfect location, waiting on permitting approvals to scuttle the platform.
Once we approached the scuttling site, then it was time to cut it loose. As she was sinking, you could see the pontoons do like this, like she broke up as she went down.
After 8 weeks of hard work and dedication, Jupiter 1 was successfully removed and sunk into 2,000 meters of water, approximately 60 miles away from the wreck location, just 8 weeks before Nate paid the Gulf quite a visit. Hurricane Nate hit the Mexican part of the Gulf on September 6th. It started as a thunderstorm in the Bay of Campeche and reached its peak intensity of 75 miles an hour a couple of days later, becoming a hurricane for 12 hours. After causing a significant impact, Nate made landfall and dissipated on September 11th. If Jupiter 1 had still been there during Nate, this operation could have taken an unexpected turn.
We are actually very lucky that we had to remove the Jupiter. Another typical meteorological event during that season are the turbanas, which is a very strong thunderstorm that could roll over the site, and we encountered several of those.
In Mexico, in the afternoons, the weather picks up, but it wasn't so much that we couldn't work. We expected a hurricane, and fortunately it never happened.
Mammoet's teamwork, professionalism, and strong sense of responsibility allow the crew to successfully perform the salvage project on its very first attempt. They were able to confront and overcome numerous hazards and difficulties, including extreme weather conditions, hurricane warnings, and the constant menace of executing a complex operation against the clock within an active oil production facility, all while putting people and safety first. This grand human accomplishment was only possible thanks to the joint efforts of all the parties involved, led by Mammoet's team.
There was a real sense of camaraderie. It was always heartening that you could call over to a barge and that's one of your competitors, but he's hopping to whatever request it is that you ask.
Altogether, it was a huge team effort that resulted in a successful job.
The Apkatoon A system owners, employees, and the rest of the community were then at ease, knowing Jupiter 1 was no longer a threat offshore.